My talk is laid out as, what are the data sources that are available for reconstructing landscapes? Stand versus landscape analysis, because it's important to do a multi-scale analysis if you're going to do restoration. And then what I call fate sheds. Where are we? What are the possibilities? Where can we go from here? And then some restoration strategies that might or may not be useful. Here are the data sources that I used for my reconstruction of the Little River watershed. It's about 130,000 acre watershed that's a major tributary to the North Umpqua River. And I used historical documents, maps, photos, landscape art. You'll see a lot of that. Toponymy, the place names. So Peter Paul Prairie is hardly a prairie anymore. And so that, obviously informs you as to what it used to be. Explorers' journals, oral history, material culture. The only thing I didn't use was sediment cores, but I did do dendrochronology. I used remote sensing information, vegetation inventories, and I try to just pull the whole kitchen sink together to put together, because really, ultimately, all you're doing is stacking up as much circumstantial evidence as possible, because you can't actually, transport yourself back in time. So you have to use the evidence that's there in whatever form it is. So, history, we have some, we have some great art. We have archaeological, we can figure out where they were, what folks were doing on the landscape, and try to look at, to sort of rebuild the land use patterns of the area. And then we can look at ecology. I have lots of data, but we also can look at things just like stand architecture. You can see important shifts going on here, can't you? You can see this open-grown tree now in the middle of a closed canopy stand. You can see a shift from white oak to Douglas fir there. And then we need to be able to decide what is it that we're going to measure. If we're going to look at changes in the land, what are we looking at? What are we measuring? And how does that help to inform us? When I first started this project, this is back in the early 90s. My major professor is sitting back a few rows back. And I went to one of my committee members and I said, well, this is what I want to do. At first I thought I was going to just study how lightning moved fire around in the forest and whether it was slope or aspect or what was happening. And then the more I looked and the more I talked to people and the more I got with the archaeologist on the forest, I realized that, oh my God, I wound up with a historian and an anthropologist on my committee. But when I first came to my forest science folks and I handed them my stuff, they said, well, this is all very interesting, but what department are you in? And then the other comment was, oh, untestable hypothesis, have fun with that. So I had to have one foot in the hardcore scientific realm where I had to generate numbers because I had to do statistical analyses, because if you can't attach a p-value to it, it's of no value. And so I struggled with this soft science, hard science thing. But you'll see, I was able to generate some numbers and put some p-values together, and so I ultimately got my PhD. But it was, let's go back to this and talk about this a little bit more before I go on. So you can look at landscape level stuff, which is what I was really focusing on. I mean, you can walk into a stand and look around and have a pretty good idea of what was going on there. But what's going on across the landscape? And more importantly, if you're going to do restoration, what are the pieces that are missing and what are the pieces that are still there? And so you need that landscape level context. So we can look at patch, corridor, and matrix configurations. What was the matrix? How were the patches arranged? How much of it was there? And how were they connected to each other? We can look at those proportions. We look at tree species proportions and distributions. What were the tree species that were there? What trees are moving in? What are their ages? And how are they configured on the landscape? And then we can look at disturbance patterns across the landscape. How did fire move across the landscape? And more recently, how did chainsaws move across the landscape? At the stand level, we can walk in and do that same kind of thing. We can look at tree species demographics, size and age structure. Again, that stand architecture, open grown versus closed canopy stands. And then disturbance history in the stand itself, or at least in nearby stands, because what you can do is you can look at the scars in the fire scars in the trees. And so I have a real love-hate relationship with clear cuts because I'm always out of the truck scrambling down looking at the stumps to see what they can tell me, you know, and because there's thousands of stories out there decomposing at the moment. So historical analysis, we have photos, sketches, documents. I have broken up, based on my research, I've basically broken up the data sets that I have into 3 different phases. What I'm calling the Aboriginal phase, before 1850, when the Indians were removed to the reservations and stopped having, at least in my area on the North Umpqua. In the South Umpqua, they read the writing on the wall and hid out instead of allowing themselves to be rounded up and taken away. So the Cow Creeks are still well established in the South County. And I've learned a lot, by the way, from Chuck Jackson and a couple of other elders from the Cow Creeks that have just been a tremendous source of information to me. But then what I'm calling the Euro-agrarian phase, mechanized to an extent, but misery whip mechanized, as opposed to chainsaws and helicopters and trucks. So in that industrial phase, we move into the mechanized operations. So what can the landscape art tell us? Well, if we look, this is a pencil sketch from September 21st, 1841, and what do we see? A landscape fire in the background. So that tells us, that gives us a place. This is actually right close, interestingly, close to the casino, the Cow Creek Casino. And so there he is, standing here, just standing by, posing for the sketch that Henry L. did. And we're looking at I pretty much can peg where that is. And looking at the landscape now, it's an entirely different landscape than we see now. Those are almost all oak madrone forests with stands of fir and other conifers down in the draws. And so there was the landscape fire. And here's the orchard of oak trees that Henry L. wrote about. I talked to Chuck Jackson about this. How come there are no grinding holes here in the area? Down in Northern California, acorns were a major food source for people, right? And what Chuck told me was that, acorns don't taste very good. They're hard to work with. They're bitter. He said, but we maintained oaks because the deer like the acorns, and we just eat the deer. That's a whole lot easier way to process acorns. Let the deer eat them and then get the deer. So, and then looking up in the uplands here, you can see, ecologically, we can see there was some big downwood here, some large trees. But also, if we kind of zoom in here, we can see some other interesting things here that we see in the background. I figure that Henry L. wasn't sketching in the morning. Everybody'd be annoyed with him if he was sketching in the morning. They're getting the camp up, they're getting going, they're moving. He's sketching at the end of the day, right, when you're sitting down. So this would be a west-facing slope here. And you see up in here, what do you see? An open, more of a savanna or a parkland grading down into a meadow, whereas on this side that faces east and would be cooler and wetter, you see a more dense stand, and you see stands in here that are frustratingly vague, like they could be fire lanes that went up there, although I don't see the burnt sticks. He didn't draw the burnt sticks in there. They could be meadows, but you see a very patchy, heterogeneous landscape there. We have the hand-drawn maps from the 1850s showing lots of grazing area, cropland and grazing area. By the 1940s, the forest has encroached back in, and by the 90s, it's gone back out again. So we can see the march. Oh, and by the way, on this one, you can start to see the squares of the BLM checkerboard show up there, where you didn't before. But in here, you're just starting to see clear cuts. Okay, in the 1940s, chainsaws are moving into the area. So instead of individual harvest, now we're moving into the chainsaw era. And that's right where I sort of draw the line between those cultural phases. Rephotography from the lookouts, using, again, those 1946 aerials, and looking at today what used to be matrix of forest with corridors of wet meadows in between along the creek benches, probably beaver benches along there, and sort of patches of meadow have now given way to basically a matrix of plantations with islands of old stands within them. So we can see this shift in landscape structure. And these drawings were done using the most sophisticated image processing technology available on the planet today. Human eyeballs. Okay? So you can do all this great, image processing and stuff, but folks at the North Umpqua Ranger District, under the direction of Ray Davis, sat and digitized this by eye. And so I consider it to be highly accurate. But interestingly enough, you see the late 1800s, you see the yellowish color, if you can't read the legend here, which nobody can. You see that is open area, or at least early Cyril as it's called. The greenish blue is mid-Cyril, and the dark green or dark blue there is the older forest. And you see that these are probably the densest forests that have ever been on there for hundreds or thousands of years, because that is the one little snapshot in time where there was no human management. There was human management clearly up until the 1850s. And I shouldn't say human management, I should say extensive human management, because the Indians now have been removed. Nobody's out there with the fire sticks, or presumably, so the forests are allowed to get probably denser than they've ever been. So rather than looking at that as the historic condition, you have to run the clock backwards and look at something more like that. Now, obviously, we've gone quite a bit in the other direction here. And the interesting thing now about what we refer to as early Cyril, meaning early successional stands, is that those stands, what used to be early successional stands were snag patches and areas that were burned and brushy areas and things like that. Now, what are early Cyril stands? Soldier rows of trees that have been planted. Okay, so archaeological analysis. What I did was, in order to be able to figure out where indigenous folks were spending their time on the landscape, and therefore where was the most intense activity, was as I created a series of least cost pathways. And the way I did that was to start with an area, and this I make this map deliberately vague because these are archaeological sites, and so I don't want to give anything away, so I just make it real vague, and but what I did was, this is Little River here, and I took 10 sites. You only see 1, 2, 3, 4, 5 of them here, but the rest of them are off the picture here because I wanted to get the context. I didn't want to just pick sites within Little River, even though that was my focus. I wanted to pick sites all around and see how those pathways crossed themselves in Little River. And so what I did was, I had something like 80 different sites digitized here, but I only chose 10 of them to run the pathways between. The idea being that as my model got better and better, it should pick up more of the rest of these sites, right? And that's how I would be able to validate my model. And so initially, when I did the first model was what I thought would be the naive model. That is, it costs you a lot of money to go uphill, costs you a lot of energy, right, to go uphill, but you get it back going downhill. Well, how many of your knees tell you that that's the case, right? So I thought this wouldn't do anything, right? Well, bam, 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 it picked up all the river camps, but it didn't pick up any of the upland camps. And so I said, okay, computer, walk on the flat ground. Walk on the easy ground. Even if you have to go longer, walk on the flat ground, because my knees tell me that's the place to walk. And so those pick up the upland sites as I force them away from the creeks. So you can't just go thrashing up the middle of a creek, right? And now what happens is that pushes those sites upland, and now that picks up all the rest of the sites, except for these little orphan sites in here, which really bugged me. So I went back and I looked at that clover site right here, and looked at the old aerials and found out that in 1940, those emergent old-growth stems were still sticking up there, but there was a young forest coming in underneath. And there is lithic scatter in that area. And so I thought, a bunch of crossroads coming there. I thought, well, let's run a line from there. And bang, picked them all up. So this, and notice, P, yay! We could now we now had a statistically significant way to say that, yeah, this is probably the easiest way for individuals to get from one place to the other, from village to village. So, and then, just quickly here, I wanted to see, here's this site, and here's the pathway went up through this area. And so I picked a clear cut, it's not in this picture now, it came later, that went down the draw into some deep, steep stuff that I figured they probably wouldn't be hanging around a lot. And then I looked at what was going on right close to the trail. And what you see is, fortunately, I had two data sets, two fire history data sets. One of them was gathered by Kelly Van Norman, who did a master's here at OSU. Another was collected by the North Umpqua Ranger District. And fortunately, I was able to, they happened to just sample from the same clear cuts in like 8 or 10 different cases. So I was able to validate their two sets of methodologies, even though they were different. They gave the same information. But look at this. 1850, bang, you get trees. If you look at the draw down below, the oldest tree germinated in the 1400s, 1600s, 17, 18, so tree, fire. Okay, so completely uneven age stands down there, lots and lots of fire, but so low intensity that they didn't take out the entire stand. You could interpret this in the traditional way and say, oh, those trees came in after a stand replacing fire. Or you could say that's afforestation that happened after the extirpation of native folks who were maintaining those upper meadows up in there. And then there's routed to reach the apex of all high points. And so the really nice thing about doing the sciencey stuff, with GIS and all that, is when you can go back and find historical documentation that corroborates your science. And so this has been a really nice mix of science and history and anthropology. As I say, I never intended to do the history and anthropology, archaeology stuff, but I love it. I love that that's what happened as in the process here. And then there's a ridge that was burned out, little trees, right, that weren't allowed to get very big before they were burned out, and somebody's burning out the camp down here in the fall, right? They're burning the camp in preparation for heading back down into the winter villages down below the transitional snow zone. So summer camps, 20, 30 miles, moms, babies, baskets and all, back down in the wintertime to get underneath the snow. And then this was a great little smoking gun that fell out of a friend of mine was at the Douglas County Museum, and there is a data set of oral histories from pioneers that were taken as a WPA project in the 30s. And they interviewed James Watson, and here he grew up in Little River, and he says, Mr. Watson's of the opinion that this was due, that is the fact that the hills are all covered with grass and there's no trees, to the fact that Indians burning off the land each year, they would fish and hunt in the hills. As winter approached, they would come down out of the hills, burning the grass and small growth behind them. No damage to the big timber. And if you look here, the Eld expedition, the guy who was doing those sketches that I showed you a minute ago, talks about coming across a woman who was blowing on a brand to set fire to the woods, probably. And she was sullen and dogged and made no response. And who would with a bunch of mounted white guys, She's going to respond. She's just going to walk away. What was she doing? Cleaning up, right? Running the fire stick at the end of the season, getting in preparation for heading back down again. And they had, the woods were on fire in several places, and we had some difficulty in passing. You think you would have some difficulty in fires in the forest today? You'd have a little more than some difficulty, right? You'd be running for your life. Okay, so things have certainly changed. Ecological analysis, we can look at the fire scars. We can not only know the age of the tree, but there's Cambion damage from a fire scar. Here's the first year of healing, second year, third year, fourth year, right? And by 10 years, that scar is gone. So you have to look at the cut discs of the tree in order to be able to put this fire history together. The two data sets that I had about 5,000 stumps in them. So that's a pretty good amount of stumps to get a good feel for what's going on landscape-wide. I just put this one, it's my favorite oak. This came right from my neighbor's property, 1805, 1808, 1811, 1813, This was a little tree, right? And it survived those fires. Did the fire stop in 1818? No, what happened? Tree got big enough to withstand those light, quick surface fires. So you can get a feel for what the intensity of the fire was by looking at where the scars are in the trees. This is a gnarly little data set, huh? This was great. This is tree origins, the green. This is fire scars, and I just again, luck just struck when this data set fell out of the sky. Lisa Gromlich, that some of you may know, was UW or here. Anyway, she wrote a wonderful dissertation where she reconstructed growth based on the widths of the tree rings. And wouldn't you know that one of her sites was in the middle of Little River? So I had this wonderful precipitation data set that I was able to compare to tree origins and fires. The hypothesis being that if Indians were in charge of the fire regimes, then we should see no pattern. Because if that huckleberry field needs to be burned, it doesn't matter whether it's a wet year or dry year, you're going to get up there and you're going to burn it. You're going to wait for that window and it's going to get burned, right? And so we should expect to see no correlation when Aboriginal management was going on, and one might expect that we would see climate-driven situation on the other side, and that is what we see. We see no correlation between rainfall and fire. We see no correlation between rainfall and tree regeneration. We see no correlation between fire and tree regeneration, because one would expect there would be that, right? Because after a fire burns through, it creates a seed bed, and you should get trees germinating at that point. If you go, I left this gap here because I wanted to look at clearly non-native and clearly native, and so I left that little space out because I didn't want the data set to be confused there. But if you look at the times from 1850 to where my record ended, you wind up with reasonably strong correlations. So now climate is driving these processes, where before Aboriginal management were driving those processes. Uneven age stands. I won't go into the details here, but just look at the pie chart. All that dark green, those are all the stands of the 180 stands that I worked with. Those are uneven aged. The little wedges here are what you would call even aged, even if you use a very liberal definition of even aged stands. That is, if you consider an even aged stand to be one that comes in within, that where 80% of the trees comes in within 3 decades, even then you only get like 6% of the landscape is even aged. These were uneven aged, intermediate disturbance-driven systems. That is, they weren't the standard forest burns down, grows back up, burns down, grows back up, the shifting mosaic that you hear that most people get taught. Okay? These were intermediate disturbance fires, and intermediate disturbance fires generate lots of spatial diversity, which generates biotic diversity, right? So we have highly diverse forests there because the fire regimes were so patchy, so crazy, so intermediate. And then here's the danger. I said I wasn't going to talk about misuse. But anyway, historic range of variability is this idea that you look over a whole range of time to see what the variation is. Instead of saying 1825, I'm going to restore this forest to 8, pick a number, right? Well, no. What you want to do is you want to see where were those where are the sideboards? Stuff shifted around between these sideboards, right? Where are the sideboards? And so my approach would be manage somewhere toward inside the sideboards, right? If you're out of the historic range of variability, then you're probably out of range. You probably ought to move back into that range. And so here, these are moist forests that everybody says are generated by stand replacing fires, right? And this is Jerry and Norm said this, and these were the stand. And so they picked a stand. They said this is a moist forest, and so we should be able to do a heavy thinning down to like 30% to create early cereal habitat, because that's how these stands worked. Well, I just picked the 4 closest stands to the stand that they laid out, and I said, does that look like a stand replacing regime there? That looks like intermediate disturbance. We have fire, 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 and completely uneven age stands all the way across there. And here, this is an interesting one too. Again, a huge landscape level data set, the Current Vegetation Survey done in 1995. If you look at the trees that germinated from the year 996, the oldest one in the record, to 1820, you see 70% are fire resistors. This is Jim Agee's term, right? Fire resistors versus fire avoiders, like they're going to get up in their little roots and run away or something. But basically trees that get hurt by fire, like true firs and hemlocks, right? As opposed to fire resistors like Doug fir and ponderosa pine. So you notice an important shift, 15% drop in fire resistors and a 15% increase in fire avoiders. Okay, now what does that say? Number one, that you take fire out of the system, you're going to get more fire avoiders too. But the other thing, and this just occurred to me when we were out in the field, Dave, with Dick Waring, and that hemlocks and true firs transpire more than Doug firs and hemlocks. And so not only do we have a situation where we have tree species that aren't as fire tolerant, we also have tree species that are pumping more water into the air. And so as global warming, if global warming or if climate change goes the way we think it's going to go and more drought is going to happen late in the year, that could be significant because we could be pumping more water. Transpiration could be sending more water into the air, stressing the trees that are already there even more. Tappener's work, Nathan Pogue's work, Tom Sensening's work all show that forests are developing on a we're going to have, if we leave forests, we'll have old growth forests. They won't be the same. They will be closed, tight, they can be old, the trees can get old, but they won't be these open, widely spaced, big open architecture type forests that we inherited. So, how's all that been working for us? Well, let's take a look at the Williams Creek fire. This burned in 2009. Surprisingly, this was an ecologically very good fire. It started here from a power line spark. They're suing PP&L now to try and get the money back for fighting the fire. And you notice, where was the fire the hottest here? Okay. Well, number one, notice that, first of all, I should mention, this is fire intensity, not fire severity. The difference is that the satellites are measuring infrared coming off the ground. This is just heat generated, energy generated, right? Well, that tells you a couple of things. First of all, it tells you pretty much what the severity is going to be, because the hotter the fire, the more likely trees are going to die. But it also tells you what's happening to the soil, too, potentially. So anyway, notice, though, how much of this forest, this is a roadless area, has never, well, it's roadless, but you'll see in a minute that it's not really. Okay, but anyway, the point here is that the blue and the yellow, there's still lots of green crowns. The blue, there's all green crowns in there. The yellow, there's a bunch of green crowns. The red, the crowns are gone. So let's take a look at some of those areas, right? The ones that burn the hottest here. And this is something that I want to do some more analysis on here. If you look at a satellite image, what do you see in the areas that burn the hottest? Plantations, 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 plantations. Here's where the fire started. Those were meadows that faced south along the North Umpqua and probably would have been burned out on a regular basis. And the trees that burned were all even-aged afforestation that happened after Indians were extirpated. Where did we get a couple of other cool hot spots? Right in there in the meadows that Danielle was talking about. Probably have lots of bear grass and probably have lots of species that have been suffering from the encroachment of the forest. And so this was pretty much an ecologically good fire, except in the areas where it burned in the plantations, just cooked them. And so the analysis that I would really like to do is, are we getting higher severity fires because there's more fuel in there? Probably so. Are we getting higher severity fires because there are more plantations in there that are even aged and therefore cook the stands around them? I would bet there is. And so that's an analysis I want to do here pretty soon. Looking at the 2002 fires, these were our biggest fires on record. While the biscuit was burning, nobody cared about our little 88,000 acre fire. But it was a huge one for us and traumatic. Well, look at the Tiller complex. Beautiful fire. Lots of crazy heterogeneity. What made the apple fire so crazy? Well, number one, there are a bunch of plantations up in there. Number two, it was an arson fire started from a single point versus a swarm of fire that went through the tiller complex. And so what that created was, and just to point out that under the worst conditions, 100-degree temperatures, single-digit humidity, 30-mile-an-hour winds, we only had 10% of the old growth that actually was burned intensely. And the plantations, 55% of them, or in the plantations that are under 20 years old, pretty much vaporized them. And so again, and actually that 10% is because so much more of the old growth that in the apple side burned, the tiller side was only 6%. And there you go. There's an example. This backed down, just nuked this whole thing. If it had gone up the hill, it would have taken out that setup above, right? But it backed down, so it didn't. This one came straight into this old growth. And do you think it stopped there? Nope. It went right up the hill, over the hill, kept on romping through the forest. That's what's left after that fire. And so that old growth sucks that fire down onto the floor and damps the spread of the fire. Here's the apple fire. Got some crazy fire weather going on in here, right? That green stripe right up the side of the hill has two tongues of the flame take off on both sides, and they do this. They suck a downdraft into that stripe, run a stripe up the middle. Is that going to happen in native stands? You don't have the perfect homogeneity of the fuel to be able to do that unless you create clear cuts and plantations. So changes in reference conditions. Just as a recap here, we've gone from multi-cohort stands to even age stands. That's the trend. We're going from average age and diameters of the trees are all decreasing. Increase in stand densities, decrease in large trees, decrease in structural and biotic diversity at both levels. If you look at shifts in fire pattern, we've gone from many small fires to few large fires. These mega fires, as Bodie was saying, frequent to infrequent, low intensity to high intensity. But again, I would caution that we shouldn't necessarily blame the increase in fire intensity entirely to fuel loading. It's the structure of the fuel just as much as the amount of fuel itself. You spread that fuel out, you make it nice and even, the fire's just going to rip through that crown. If you have all kinds of crazy heterogeneity in there, it doesn't matter how much fuel you'd have. A lot of those stands are going to survive. 5 o'clock in the afternoon, 100 degrees, single digits, okay. Nothing's going to withstand that. But all night long, this fire is creeping around unless it hits a plantation. Changes in the management footprint. We've gone from corridor and yard openings, corridor and yard. That was a term that was coined, I believe, by Henry Lewis, who some of you may know, anthropologist, archaeologist, who did a lot of work and found that the world over, that is the pattern that indigenous people put on the landscape with fire. Corridor and yards. They create yards where it's flat, where there's good food. There's obsidian there are obsidian points in every archaeological site on the Umpqua. There's no obsidian on the Umpqua. Clearly, they were traveling to get the obsidian, bring it back, and make it into points, right? And so they'd get up on the ridges to travel because stone axes weren't going to keep the roads open, right? What was going to keep the roads open? Fire. And so up on the ridge, you could move. And indeed, why did we see those sketches in the Wilkes expedition up on the ridges there? Because those were the old Indian roads, and they were using the Indian roads. And so creating these corridors generally along the tops of the ridges, as opposed to down in the draws. When Europeans began to make roads, what did they do? They would follow the creeks, right? Because they had lots of animals and they needed water. The Indians just had a spring here and a spring there. They burned it out the previous year. They'd show up to make sure the table was set, right? And the animals come to you. You burn in the right pattern, and you bring your food to you instead of having to go after your food. Ridge and river to whole landscape. Extensive, lots of light burning, small burning in lots of places, to intensive, clear cut or heavy stand reduction. And then the major disturbance agent has gone from fire to logging, and we've gone from systemic ignition to systemic suppression. So, where are we going? Well, we've got some problems. Okay? We've got exotic species, we've got loss of legacy structure, we have an aging road system, extirpated keystone species, demands for resources in a changing climate. Okay, so what do we do? Do we restore, do we remodel, or do we renovate? It's contractor terms here, right? So restoration, you're going to take that 1850 house and you're going to put the same brass doorknobs on it that it had. You're going to have the same molding, the same paint. And you're not going to put heat and grounded wiring in. You're restoring it, right? Remodeling it, you're going to put a new addition on over here. You're going to change the function of the place by adding something to it. Or renovation, you're going to get that knob and tube wiring out of there. You're going to put Romex in there. You're going to put modern plumbing. You're going to take the bathroom off the back porch and put it in the house, right? So that's the metaphor that popped into my head late last night, and I thought I'd go with it here. And so restoration, what do you want to restore? What do you want to restore? Okay, cultural sites, certainly. Right? They did that in the Medicine Creek Caves on the Umpqua, these beautiful paintings on the rock shelter, that little guy with the bow and arrow that I showed you earlier. And what had happened was all the trees, there were lots of big ponderosa pines spread out in front of that cave, but there were also tons of firs that had come up in the intervening years. Well, the Forest Service got tired of picking the lichen off the rock walls because it got so cool and moist in there that it just started growing and covering up all the rock art. So what did they do? They finally thinned out and opened it up so sunlight could come in and protect the rock art. That's restoration. That's the kind of stuff that we need to be thinking about doing. Endangered habitats, beargrass habitat, like Danielle was talking about before, or environments that are being encroached, meadow communities, native grass prairies, things like that are horribly endangered. Let's restore those. Keystone functions. Let's bring some beavers back and plug them in. Beavers controlled the hydrological regimes. Native Americans controlled the fire regimes. We can put the beavers back and they'll do what they do. But that's where we need the TEK, because we don't have that keystone species anymore. I mean, we do. They're here, of course, and they need to inform us so we can become the new indigenous people. Okay? Working with the elders, we need to become indigenous again. We need to take that European stamp off the landscape and talk to the elders, get the information, and start behaving like we live here. Remodeling, you might want to do a stand conversion. You might want to take a plantation and convert it to an oak pine savanna. You might want to do afforestation. You might want to take a piece of, probably not, but that would be an example there. And renovation, we got a road and a trail system that's in bad shape. And what really needs renovation is our management models. Okay, how we think about managing. So you plan at the landscape level, the fifth field watershed level. How do we know what we need to do to stands? Obviously, you're going to manage at the stand level, right? The chainsaws are going to hit the trees, or the fire stick is going to hit the stand, right, at a particular place. And so you need to know before you decide to convert. For example, some folks from the BLM took us out and showed us the stand. We went to that stand they were proposing, it had been an oak pine savanna, they were proposing to take it back to being an oak pine savanna. Well, at the moment, it's an oak pine savanna that's full of Douglas fir and is actually functioning owl habitat, right? So are we going to take one rare habitat and convert it to another rare habitat? Doesn't it make a little more sense to take a common habitat like the even-age stands that we've got proliferating all over the landscape now that we're only here in very small proportions, and turn that into an oak pine savanna? Right? Makes a little more sense to me. So you need to understand what's going on. You can't just make a blanket statement and say, early cereal habitat is rare right now, and so we need to convert that. Well, show me. And if it's true, I'm with you. But show me. Do the landscape level analysis. And everybody gives that lip service, but I hardly ever see it being done. And so landscape level goals, we might want to reconnect ridge and river corridors with yards and parks. We want to shift back to lower density multi-cohort forest matrix. We might want to restore keystone species and keystone ecosystem functions out there. I think that's a pretty important thing to do. And we need to think about, on public lands anyway, and I can't say anything about private lands, but on public lands, produce habitat first and commodities second. Commodities should be a byproduct of restoration. Now, if industry wants to come to the table, then we can talk. But right now, they only show up at the table when they want more cheap timber from the feds. And so if you want to be a full partner, come on in. We need a forest, we need the equivalent of a watershed council. We need a set of forest councils. Kitts Harbor developed the watershed councils back in the mid-90s. It's time to start, calling them up and saying, hey, let's do that again for forest councils. Because as you may or may not know, as soon as you get out of the riparian area, all bets are off on the watershed councils. Right? Watershed councils aren't watershed councils. They're riparian area councils. And so nobody dares go out of the riparian area and get up. We need to grow up, get together as communities, form councils of elders, managers, take a page from our predecessors who managed the land before us and start looking at new models and new ways of managing the forest. Stand level, convert overabundant habitats to rare habitats. I just mentioned one. Use landscape fires first and chainsaws second. Everybody is petrified of fire. We need to have a priori agreements with private landowners around. We burn it, we buy it. Simple. Okay, here's the formula. Well, we'll work to the 97.5 percentile, weather and fuel sticks and all that sort of stuff. And if we blow it 2.5 times out of 100, we'll pay you. Okay, and then we can use fire first. Let it burn in the way it normally did. Let it do what it normally does, and then think about chainsaws second. Now, there may be places where the fuels are too intense. There may be places where you need to do some fuels reduction ahead of time. But chainsaws are expensive. Disposal of the slash is expensive. Then the fire is expensive. If you just burn the fire, you've taken out 2/3 of the cost of doing the management. So what might that look like? If you had a ridge system, you could create some meadows with interspersed savanna in there so that you can get animals that like open country through there, elk, deer, those sorts of things. But you also need to be mindful of getting riparian obligates from one side of that ridge to another.